Mobility is one of the key factors of the success of operations. So if our troops are not mobile, that means our troops are vulnerable, our troops are exposing themselves to the threat, and on the other hand are not able to be proactive and outmaneuver the opponent, for example.
Even though I'm an Air Force member, I realize the importance of ground mobility, and I've witnessed firsthand during my career the problems that troops can encounter when they have issues on the ground. So I've seen people become mired in the mud and become targets, leading to their untimely deaths. Fatalities from crushing injuries, from rollover accidents, and I've also unfortunately seen countless deaths due to drowning in canals when vehicles have tipped over in our combat theaters. But additionally, mission completion can be jeopardized, and you can extend timelines, and ultimately you're not going to meet your mission objectives if we can't get to where we need to go.
We can predict mobility in several ways. Most obviously, we can have a look at the weather. We can look at the geographical situation and try to predict the impacts on mobility. What we are doing with our NATO task group is to bring it to the next level and also interpolate by digital tools the way that our vehicles will behave in a certain environment.
The critical elements for predicting mobility is, well, first of all, we have to understand the dirt that we're traveling over. We have to understand the strength of that soil and then how the vehicles, wheeled or tracked, interact with that soil. It is all about the terra mechanics. It is about that vehicle to soil interaction under all conditions, worldwide and year-round. Thawing soils after the wintertime, muddy soils after heavy rain, very dry soils in the desert. Being able to understand and predict the performance of the vehicles over that very broad range of soil conditions that are found worldwide.
It takes into account the consistency of the terrain, the temperature, the humidity, and in a most realistic way will represent reality. The previous reference mobility model is based on work which was conducted in the 60s and 70s, and also the data was collected during those decades. The next generation mobility model is not anymore based on empirical data collection, but on the digital formats, and also is able from those digital data extrapolate predictions beyond that what was collected in experiments and data exploitation.
Over my career, I have had the opportunity to deploy worldwide. When we were very dependent on measured vehicle cone index and using the historic NATO reference mobility tool that was developed, with the resources that were available in the 70s and 80s, that methodology, honestly, as vehicles progressed, was wrong. It gave us information that was inaccurate. And when I was in an operational situation and we were using all the tools that we had available, with our forward deployment of reconnaissance and our combat engineers, we got stuck and we got hit. What I have experienced in this development of the next generation NRMM gives me absolute confidence that had that tool been available at that time, we would have avoided that area and we would not have been hit, and lives would have been saved.
We can talk about the operational benefits, but we can also talk about acquisition processes and decreased cost and time for the development of new vehicles. So digital prediction of mobility will enable NATO to outpace our opponents in several aspects.
The advantage to NATO with this effort is that currently there's a very broad range of vehicles that are deployed within NATO, represented by all the different countries. There are different vehicle types, different vehicle capabilities. Some vehicles are very good, let's say, in the mud. Other vehicles are not. Now it is possible for the different countries to be able to consistently compare the capability of their vehicles to the capabilities of other vehicle systems that are deployed at the same time. This is a huge advantage to the operational commander, because now as forces from, let's say, Canada and forces from the UK and forces from Germany now all come together, in a cohesive battle front, understanding that the vehicles are able to negotiate the terrain, understanding the speed that they are able to negotiate, putting the most capable assets directly against the threat vehicles as a function of mobility. This capability is significant. It goes far beyond what we have right now, which is maps. The map may say, there's something growing there and maybe that's bad and I can't drive through there. With this capability, the integration of the digitization of all the terrain using GIS technology, the application of the simplified terrain mechanics, which now define how the vehicle and the soil interact and therefore help us understand, can I climb that 20% grade or not? And therefore I need to avoid it and go around, or can I negotiate that obstacle? Now throughout NATO, the ability to directly compare the capability of the tactical vehicles and the combat vehicles and then deploy successfully should be a significant advantage moving forward. As more and more countries are able to bring data on their vehicles forward, now this information will support the life of the vehicle. What happens when we have to add armor? Or what happens when we change the center of gravity because we added a new weapon system? Now this tool will aid in accurately understanding the influence of those vehicle changes through their 20 or 30-year life on their mobility and the terrain that they can negotiate.
This AVT 308 cooperative demonstration of technology really is the culmination of multiple years of work in order to provide a strong set of standards to propel NATO into the future and improve interoperability of our ground systems for the long haul.